Hello dear students and welcome to part 2 of the PYQ solutions. If you have missed part 1, then I have attached the link in the description, and also on the top left you can access by clicking on the I button. Let's get started with question 1, sub question D. This particular question is based on successive differentiation, and we are given a function y, which is a rational function. In the numerator we have got 2, and in the denominator we have got x plus 1 whole square times x minus 2. So we are going to first of all take help of partial fractions, which you are quite familiar with. So we are going to express y, which is given to us as this, as a over x minus 2 plus b over x plus 1 plus c over x plus 1 whole square. Our objective is going to be to find out the values of a, b and c that satisfy this particular equation. And considering the second and the third expressions in equation 1, we'll just multiply by the denominator, which is x plus 1 whole square, x minus 2. We will be getting 2 times of a into x plus 1 whole square plus b into x plus 1 into x minus 2 and plus c into x minus 2. Now to find out the value of a, we should be substituting x equals to. So if we put x equals to 2 in equation number 2, we get the left hand side remains as it is, and this is going to become 2 plus 1 whole square. Now here we can see that we have a factor x minus 2, so this entire term will become 0. And likewise here also we have a factor of x minus 2, so the third term also vanishes. So this gives us 2 is equal to 9a, and therefore we get a is equal to 2 over 9. Now for the next one, we are going to substitute x equals to negative 1. Again back in equation number 2, and this is going to give us 2 is equal to. Now first let us see the terms which are going to get vanished. So here we have a factor of x plus 1 whole square, so this will become 0, and here also we have a factor of x plus 1, so this will also become 0. So we will be only left out with the third term, so this is going to be c negative 1 minus 2, and that gives us 2 is equal to negative 3c, and therefore we get c is equal to negative 2 over 3. So we have got the value of a and c, and we still need the value of b. So for that we are going to take any random value of x, a simpler one. So let us say x is equal to 0. So we will be putting x equal to 0 in again equation number 2. The left side remains 2. Now on the right nothing will vanish, so we will have an entire expression involving a, b and c. So the first term is going to be a, the second term is going to be b into 1 into negative 2, and the third term is going to be c into negative 2. So this simplifies to a minus 2b minus 2c. Now substituting the values of a and c that we have obtained in the last expression, we will be getting 2 is equal to 2 over 9 minus 2 times b minus 2 times of 2 into 3, 2 upon 3, so that's going to be 4 over 3. And now you can see that we can get rid of the factor 2 from both the sides, so we will be having 1 over 9 minus b plus 2 over 3. So from here we get that b is equal to 1 by 9 plus 2 by 3 minus 1. So that simplifies to 1 plus 6 minus 9 over 9, and that is going to give us the final value of b, which is going to be negative 2 over 9. So we have got the values of a, b and c. So putting these values back in equation number 1, we can say that y is equal to 2 over 9 into 1 over x minus 2 minus 2 over 9 into 1 over x plus 1 and minus 2 over 3 into 1 over x plus 1 whole square. Our objective is to find out the nth derivative. So for that we are going to take help of the formula. If y is equal to 1 over ax plus b raised to m, then its nth order derivative denoted by yn is given as minus 1 raised to n into m plus n minus 1 factorial divided by m minus 1 factorial into a raised to n divided by ax plus b raised to m plus n, and this formula is applicable for every natural number n. Now let's apply this formula to each of the three terms on the right side. So we are going to apply it once here, then another time over here, and for the third time we will be applying it here. Now let us rewrite this in the form. So we can write this as x minus 2 whole raised to 1, x plus 1 whole raised to 1. So we have got the values of m, a and b. In the first expression, which is this, we see that a is equal to 1 and b is equal to negative 2, while the value of m is 1. In the second one, we have again a equals to 1, b equals to 1 and m is also equal to 1, while in the third one we have got a equals 1, b equals 1, while m is equal to 2. So let's apply the formula now. So therefore we can say that yn is going to be 2 by 9 is a constant, it stays out. So we will be having minus 1 raised to n. Now in the first expression, since m is 1, we can see that 1 minus 1 goes away. So we will be having only n factorial in the numerator, and likewise m minus 1 will become 0. So we will get 0 factorial, which is 1 in the denominator. So we have got this. And then a raised to n, since a is 1, we can avoid writing 1 raised to n. And in the denominator, we are going to have x minus 2 power n, since power n plus 1. The second term would be 2 by n minus 1 raised to n, n factorial divided by x plus 1 raised to n plus 1. And the last term is going to be 2 by 3 minus 1 raised to n. Now over here, since m is equal to 2, if you substitute m equals to 2, you will be getting n minus 1 factorial in the numerator, and in the denominator we will be getting 1 factorial, and a raised to n again is going to be 1 raised to n, along with we will get x plus 1 raised to n plus 2. So this is the third term, the nth order derivative of the third term. And now we are just one step away from the final solution. We got to make certain simplifications by factoring out common terms. So we can see that negative 1 power n is common across. We can also factor out n minus 1 factorial. And from the constant, we can factor out 2 by 3. Thus, in the first term, we will be left out with n divided by 3 times of x minus 2 power n plus 1. From the second term, we will be having again n divided by 3 times of x plus 1 raised to n plus 1, while from the last term we will be having only negative 1 over x plus 1 raised to n plus 2. So this is where you can leave your answers. So this is the final solution for question 1D. Now let's move on to question 1E. This problem is based on the module expansion of functions, and you can see we are clearly told to apply Taylor's theorem and find the approximate value of f of 11 over 10, where f of x is given this cubic polynomial. We'll be first looking the value at which we need to evaluate the function. So let us say x is equal to 11 over 10. So this is going to be 1.10. Now the nearest integer close to this number is 1. So we will be interested in the evaluation of f of x and its derivative at 1. So f of x is equal to x cube plus 3x square plus 15x minus 10, and this gives us that f of 1 is going to be 1 plus 3 plus 15 minus 10, which is equal to 9. Then this first order derivative f dash of x is going to be 3x square plus 6x plus 15, and this gives us that the first order derivative of f at 1 is going to be 3 plus 6 plus 15, that's 24. The second order derivative is going to be 6x plus 6, and so we get that the second order derivative of f evaluated at 1 is going to be 6 plus 6, which is 12. The third order derivative of f is going to be 6, and since it's a constant, this also is going to be 6. Now you see that we have reached constant, so we know that the nth order derivative of x is going to be 0 for all n which is greater than or equal to 4, and this also gives us that the nth order derivative at 1 is going to be 0 for all n greater than equal to 4. Now we will first apply Taylor's theorem. So by Taylor's theorem, f of x is equal to f of a plus x minus a into f dash of a plus x minus a square over 2 factorial into f double dash at a plus x minus a cube over 3 factorial into f third order derivative at a plus x minus a raised to 4 over 4 factorial into f fourth order derivative at a, and so on. You remember that we have got this nice number which is the closest whole number to 1.10. So we are going to consider that value as a. So we'll set a is equal to 1. So we will be getting, therefore, f of x is equal to f of a, and please note that we have got these values already evaluated, so we'll be substituting it directly. So f of a is going to be 9 plus x minus a, that is x minus 1 into f dash of a, which is 24, plus x minus 1 whole square over factorial of 2, which is 2 into 12, plus x minus 1 whole cube divided by factorial of 3, which is 6 into 6, and onwards this we have 0. So we can rewrite this in simpler form. So this is going to be 9 plus 24 x minus 1 plus 6 into x minus 1 whole square plus x minus 1 whole cube. So this is the expression for f of x. Now we are looking out for f of 11 by 10, which is equal to f of 1.10. Here, since x is equal to 1.10, and if you will observe the last expression, all terms on the right side are having x minus 1. So from this we will be finding out the value of x minus 1, which is going to be 0.10. So therefore f of 1.10 is going to be 9 plus 24 into 0.10 plus 6 into 0.10 square plus 0.10 whole cube. You can use your calculators to get the value. I'll be writing down the final value directly, and we get the answer to be 11.4610. So thus we can say that f of 11 over 10 is going to be 11.4610. Now one thing good about such problems is that you can always verify your answer directly. So since you know the polynomial and you know the value at which you have to evaluate the polynomial, you can use your calculators or do it manually and always cross check your answers. So that's question number 1E carrying 5 marks from the module expansion of functions. Now let us head to the next sub question, which is 1F. We are given a degree 6 equation x raised to 6 plus 2 equals to 0. We are asked to solve and then further find their continued product. So by this part means that the continued product of the roots. So let's get started. So we'll start with the equation. We can rewrite this as x raised to 6 is equal to negative 2, and in complex form it is going to be negative 2 plus 0i. And further, the polar form of this is going to be, so for the polar form, if your complex number is x plus iy, then r is evaluated as square root of x square plus y square, the positive square root, and theta is evaluated as tan inverse of y by x. So in this case, you can see that x is negative 2 and y is 0. So the value of r is going to be 2, whereas theta is going to be y over x. So that is going to be tan inverse of 0. And tan inverse of 0 will be giving you two values. One on the positive x-axis, which is 0 radians, and another one on the negative x-axis, which is 5 radians or 180 degrees. So in this case, you can see that your number is negative 2, which lies on the negative x-axis. So we will be saying that the argument or the theta value is going to be pi plus I times sine of pi. So this is the first part. You need to convert your constant expression given in the equation into polar form. Now, since we know that cos and sine are periodic functions with period 2 pi, so we can rewrite this equation as cos of 2n pi plus pi plus I times sine of 2n pi plus pi. And let us close the bracket. Now, since we have introduced n, we got to tell what n is. So we'll just say that where n takes the values starting at 0 and goes up to 6 count. So that is going to be 0, 1, 2, 3, 4 and 5. So this is the first part wherein you have written x raised to 6 in polar form, and then further you have increased the argument by 2n pi. Now for the next part, we will move away the power 6 from the left to the right. So we will be getting 2 raised to 1 by 6, and then the power of 1 by 6 will also affect the cos and sine part, the cis theta part. So this is going to be 2n pi plus pi I times sine of 2n pi plus pi raised to 1 over 6. And by De Moivre's theorem, which says that cos theta plus I sine theta, the whole raised to n, is equal to cos of n theta plus I times sine of n theta. Thus, the power 1 by 6 can be multiplied with the argument, and also simultaneously we can see that here we can make the argument simpler by taking pi common. So this is going to be 2n plus 1 pi, and then let us bring the power 1 by 6 also. So this is going to be pi by 6 plus I times sine of 2n plus 1 pi by 6. And make a note that n takes these 6 values. So the moment you start plugging in those values, you are going to get the roots. So we'll start with n equals to 0. So putting n equals to 0, we will get x0, which is the one of the roots. So which is going to be 2 raised to 1 by 6 into cos of, when you plug in n as 0, this will become 1. So this is going to be pi by 6 plus I times sine of pi by 6. Then when you plug in n equals to 1, we will be getting x1 is 2 power 1 by 6. Now if you will make a note that this constant multiplier, which is the 2n plus 1, it represents odd numbers. So when you put n equal to 1, you will get the next odd number, and that is going to be 3 pi by 6, which gives us pi by 2 plus I times sine of pi by 2. Plugging in n equal to 2, we will get x2, which is going to be 2 raised to 1 by 6 cos of pi pi by 6 plus I times sine phi pi by 6 n equals to 3 gives us x3 is equal to 2 raised to 1 by 6 into cos of 7 pi by 6 plus I times sine of 7 pi by 6 n equals to 4 will give us x4 is equal to 2 raised to 1 by 6 into cos of 9 pi by 6, which is going to be 3 pi by 2 plus I times sine of 3 pi by 2. And lastly, when you plug in n equal to 5, you get x raised to 5 is equal to 2 raised to 1 by 6 into cos of 11 pi by 6 plus I times sine of 11 pi by 6. On simplification, these values are going to be these. So these are the 6 roots that we are looking out for. 1, 2, 3, 4, 5 and 6. Now moving on to the next part, which talks about the continuous product of the roots. So the continuous products of the roots is denoted like this: pi from n equal to 0 up to pi, since we have got that as the range, x n. So that is going to be the product of all these 6 roots. So this 2 raised to 1 by 6 is going to be multiplied 6 times. So that is going to give us 2 raised to 1 by 6 raised to 6. And for the other part, we are going to write down cos of pi plus I times sine of pi. Now let us see what pi is going to be. So pi is the sum of all the 6 arguments that we have got. So it means that pi by 6, pi by 2, all these 6 arguments. So let us take the sum of these 6 arguments. So the first argument was pi by 6. The second one we simplified and wrote it as pi by 2, but it was 3 pi by 6 plus 5 pi by 6 plus 7 pi by 6 plus 9 pi by 6 and last plus 11 pi by 6. So if you will take the sum of all these, you are going to get 36 pi by 6, which is equal to 6 pi. So therefore, the product of the roots is going to be pi xn, where n is from 0 to 5. The first term will become 2 into cos of 6 pi plus I times sine of 6 pi, which is going to be only 2. So this concludes 1f. So thus we have seen in the first 2 videos of this section the 20 marks, and these 20 marks can be easily obtained. In the next video, I'll be uploading sums solved from question number 2, which are 10 marks problems. So we do expect them to be lengthier. You can watch them at your own pace, or you can skip the parts which you think you will be knowing well. Right. So thank you so much for watching till here. Happy learning and all the very best.